The deployment service is for deploying and undeploying compiled modules and for returning deployment information. The deployment service provides these functions. The deployment service can deploy a compiled module. The compiler outputs an EP-compiled instance when compiling a module. The deployment service does not allow fire and forget queries. The deployment service can roll out a collection of compiled modules. A rollout can be an all-or-nothing operation, and the deployment service can detect dependencies between compiled modules and make sure they deploy in the right order. The deployment service can undeploy a deployment given a deployment ID. This removes the deployment. The deployment service can undeploy all deployments. This is handy for quickly removing all deployments. The deployment service returns information about deployments. It returns the deployment IDs of all deployed modules. Returns a deployment, an EP deployment instance, given a deployment ID. Returns a statement, an EP statement instance, given a deployment ID and statement name. Remember, the statement name is unique within the deployment. It returns the EPL object dependencies consumed and provided by a deployment given the deployment ID. It allows to add and remove deployment state listeners that receive callbacks upon deployment changes. The deployment service deploys and undeploys compiled modules. The deployment ID uniquely identifies a deployment. The deployment ID is a string-type value and can be any string. To deploy a deployment, with the deployment ID generated by the runtime, the code is EP deployment equals runtime.get deployment service.deploy parenthesis compiled. To deploy a deployment, with the deployment ID provided by the application, this is what the code look like. Deployment options equals new deployment options. Options.set deployment ID parenthesis deployment ID. EP deployment equals runtime.get deployment service.deploy parenthesis compiled options. To undeploy, get the deployment ID and then call runtime.get deployment service.undeploy parenthesis deployment ID. The deploy operation loads classes, resolves EPL object dependencies and starts statements. The deployment options class has many options, such as for overriding statement names or for attaching an application-provided object to the deployment. The undeploy operation stops statements and frees references to classes, letting the garbage collector eventually collect classes. The slide discusses the EP deployment class, which represents a deployment. The EP deployment is a read-only value object that represents a deployment. It returns information about the deployment. It returns the deployment ID, which is the string-type identifier that uniquely identifies each deployment within the runtime. It returns the statements. The EP statement class represents a statement. So it returns an array of statements corresponding to the statements in the EPL module that was compiled. It returns the module name. It also returns module properties such as module imports, uses and EPL text. The module properties can return an application-provided user object, that the application provided to the compiler at the time of compilation. The EP deployment also returns the deployment ID of all deployments that this deployment depends on, in respect to EPL object dependencies. The deployment service may fail to deploy or undeploy, and this slide discusses the common fail conditions. A deploy may fail when an EPL object that the deployment needs cannot be found. For example, when a preconfigured event type that was defined at compile time is not defined at runtime. A deploy may fail when application classes are used in the EPL but cannot be resolved at runtime. A deploy may fail when the deployment ID is already used by another deployment, A deploy may fail when application extension code cannot be found, for instance, when an extension data window is not found. An undeploy may fail when other deployments depend on an EPL object that the undeploying deployment provides. For example, deployment D1 defines an event type E and deployment D2 depends on the event type E and we are undeploying deployment D1. The class that represents a statement is EP statement. A statement is uniquely identified within a runtime by deployment ID and statement name. EP statement is a read-only value object that represents a statement. EP statement returns information about the statement. The getName method returns the statement name. The getDeploymentID method returns the deployment ID. The getEventType method returns the event type of output events. The getUserObjectCompileTime method returns an application object that was provided by compiler options at compile time, or null if not provided. The getUserObjectRuntime method returns an application object that was provided by deployment options at deployment time, or null if not provided. The getAnnotations method returns the statement annotations. The getProperty method returns the EPL text, depending on compiler settings, since by default the compiler does not save the EPL text. There are two ways to get statement results. An application can receive statement output via callback. An application can also iterate a statement to read current results. Most often an application receives output via callback, either by adding listeners or by setting a subscriber. The runtime notifies the listeners and the subscriber, if any, when there is output. Use the addListener method for adding listeners. Your application can add one or more listeners. When the statement has output, the runtime delivers the output to all listeners that are registered. Use the setSubscriber method for setting a subscriber. Your application can only set one subscriber. When the statement has output, the runtime delivers the output to the subscriber if a subscriber is registered. Instead of receiving callbacks and having the runtime notify the application can also iterate a statement and get current statement results. This is a request-response or pull-style way of interacting with statements. Use the safe-iterator method to safely iterate current statement results. The safe-iterator method obtains a statement partition lock to make sure there is no concurrent modification of state. But, the application must make sure to invoke the safe-iterators close method to release the lock. This code snippet obtains a safe-iterator and closes it. Safe-iterator equals statement.safe-iterator. Try. Finally. Safe-iterator.close. EP statement also has an iterator method. The iterator method returns current results without locking and may thus be unsafe since there could be a concurrent modification depending on runtime event processing or time passing. Here is the output when iterating the statement. Select count star as CNT from withdrawal. The result is an iterator of one event bean that has a CNT column that contains the current count of withdrawal events since statement start. The most common way to find statements is by using the deployment ID and statement name. Add the @name annotation to name a statement. To illustrate, here's the complete code to compile. Configuration configs equals new configuration. Configs.getCommon.add event type withdrawal.class. Compiler arguments args equals new compiler arguments. EP compiled equals EP compiler provider.getCompiler.compile parenthesis CPL args. Note the name parenthesis SDMT1 which sets a statement name. The complete code to deploy and get the statement is EP deployment equals runtime.get deployment service.deploy compiled. EP statement equals runtime.get deployment service.get statement parenthesis deployment ID comma statement name. The statement name can also be set by code. The compiler options object, used with the compiler, and the deployment options object, used when deployment, can assign a statement name. The options can also attach an application-provided object to the EP statement. Annotations can add additional information to statements. This example shows how to using application annotation classes with statements. First, define an annotation. This example is a Java annotation. Public at interface my annotation. The sample EPL is at my annotation select star from withdrawal. Before compiling the EPL, add the package name of the annotation to the compiler configuration under the import settings. The code below deploys and loops through all deployed statements and their annotations. EP deployment equals runtime.get deployment service.deploy parenthesis compiled. For EP statement deployment.get statements. For annotation statement.get annotations. If annotation instance of my annotation equals parenthesis my annotation. The runtime delivers output events to application code that implements the update listener interface. The update listener interface only has a single update method. The update method takes the following parameters: an array of event bean that contains the new events, the insert stream; an array of event bean that contains the old events, the remove stream; the EP statement instance of the statement that produces the output events; the EP runtime instance of the runtime. The new events and the old events parameters can both be null, depending on the EPL of the statement. The runtime delivers events as an array. It delivers multiple events in a single call to the update listener. Add the update listeners to the statement using statement.add listener. After adding the listener to the statement, the runtime delivers output events to the statement listener. The example code below print the CNT column of new events. Public class myUpdateListener implements updateListener. Public void update parenthesis event bean array new events comma event bean array old events comma EP statement comma EP runtime. For int I equals 0. I less than new events dot length. I plus plus. System.out.println parenthesis new events brackets I dot get parenthesis CNT. This slides presents the event bean interface. The event bean associates an underlying event object to an event type. The get underlying method returns the underlying event. The get event type method returns the event type. Following our previous discussion of withdrawal events, the get underlying method returns the withdrawal application object. Further event bean methods are: the get method receives an event property name and returns the event property value. The get fragment method receives an event property name and returns the event property value as an event bean or an array of event bean, provided the value consists of events. The event type interface provides type information. Every event in Esper has an event type associated to the event. The getName method returns the event type name. The getMetadata method returns metadata such as the module name, if applicable, and the visibility and scope. The getUnderlying type method returns the type of the underlying for instance, withdrawal.class, or map.class, object array class etc., depending on the event representation. The getPropertyType method takes a property name and returns the type of the event property. The getGetter method takes a property name and returns the getter. Getters are fast readers of a named property. The getPropertyNames method returns the event property names. The getPropertyDescriptors method returns event property detailed information. There are additional convenience methods. Subscribers are another way of receiving output events from statements. Subscribers offer a strongly typed result delivery matching the select clause. When using subscribers, there is no listener interface that needs to be implemented. There can be only one subscriber per statement. Subscriber code must have an update method matching the result types as selected in the select clause. The runtime calls the subscriber update method and passes statement results. This example EPL outputs the account ID and the amount of each withdrawal event. Select account ID, amount from withdrawal. Assume that the account ID is a string and the amount is a big decimal. A subscriber must have an update method that has parameters that match the select clause. So in the sample select clause it is selecting a string and a big decimal. Therefore the update method should take a string and a big decimal. The sample subscriber code has an update method that takes a string and that takes a big decimal. To set the subscriber, call statement.setSubscriber. There are other programming interfaces that the runtime provides. The training material does not cover all programming interfaces, but it does cover the most important ones. Prepared statements are for use when deploying the same compiled module multiple times with different parameters. But contexts, discussed later, are a lightweight solution to parameterizing EPL. The statement object model and module object model are for writing code in EPL without having to use string-type texts. The object models can round-trip compile from into EPL. There are application unit testing helpers for developing applications that regression test EPL. The event render service for converting event bean instances dynamically to JSON or XML. The fire and forget service executes fire and forget queries. This slide and the next slide discuss threading and locking. The runtime is thread safe. The runtime performs fine-grained locking at context partition level, or at the statement level for statements that do not declare contexts. Contexts are discussed later and can partition statements. The runtime does not create any threads for event processing, unless configured. Each event and time is an atomic unit of processing against each context partition of statements. Statements without context have one context partition. Event processing happens in the event sender thread when calling runtime.send event. But output can change depending on threading. For example, consider the pattern A followed by B. So the pattern is looking for an event A followed by an event B. When using multi-threading, the event B may process before event A, depending on your threading and arrival queue and overall technology stack. Thus a design should consider the degree of parallelism in EPL design and depending on runtime container code. The runtime invokes listener and/or subscriber code in the send event caller thread or timer thread. Context partitions are a good design choice for a high degree of parallelism. Contexts are discussed later. Input, processing, output can be handled by thread pools. If an application requires it. It is a trade-off context switch versus latency versus point of failures. The runtime has an advanced threading configuration.